Okay, children, now we are going to discuss uh, the pH tute I gave you in that pH MCQ tute that we are going to discuss from the question number 19 onwards. We are going to discuss from the question number 19 onwards, right? So, question number 19 we have already done. So, we are going to question number 20, right? So, yeah, question number 20, that is what we have discussed. So we are starting from the question number 20. Now, if you have the handout with you, the question 20 says that which one of the following indicator is more suitable for titrating ethanoic acid 0.1 moles per cubic decimeter sodium hydroxide. So here there's a titration between ethanoic acid and 0.1 moles per sodium hydroxide. So the titration is doing. We are doing titration. So this is the titration. The titration is doing with sodium hydroxide. Is titrating with sodium hydroxide is titrating with ethanoic acid. So ethanoic is what? Ethanoic acid. The ethanoic acid is CH3COOH. So this is a weak acid. You all know that ethanoic acid is a weak acid. So this is a strong base and weak acid titration. Strong base and weak acid titration. Now, when I concern in this kind of titration, the pH curve, if I draw the pH curve for this one, the pH curve will be this way. This axis we take volume of sodium hydroxide, and this axis we take the pH value, and here it is 7, here it is 14, and here it is 0. So now this one, now weak acid, ethanoic is a weak acid. The weak acid has quite a 3-4 like pH value, not 0-1-2 like 0-1 is a quite stronger pH value. The weak acid has somewhat 3-4 like pH value. So we are starting from the ethanoic, which is a weak acid. So then we start from the 4 or close to 4 like this way, and then it makes a bigger change when it close to the uh, end point with a higher gradient like this manner. So, and it goes to sodium hydroxide, is very high pH. So this is the weak acid CH3COOH, and this is the strong base that we call sodium hydroxide. So you see the first answer, bromothymol blue. If you refer the data booklet, page number 19, bromothymol blue, the pH range of the bromothymol blue is somewhere here. I write bromothymol blue. Bromothymol blue pH range is this area, so it is not suitable indicator. Bromothymol blue also not suitable indicator. Bromothymol base, the bromothymol base, the pH range is somewhere here. So the bromothymol base pH range overlap with the quick pH change. So therefore, that is the suitable indicator. So the answer is third one, or C is the answer. Then I go to the next question. Of that tute. The next question is, what is the conjugate base of acid CH3COO minus? What is the conjugate base of the acid CH3COO minus? So now see that it's something like this. HCO3 minus reacts with the water, and now in this kind of incidence, where HCO3 is there with the presence of water. Now this H plus is donated to water molecule. So this acts as a bronze chloric acid because it donates H plus. So water gain that H plus and it makes what? H3O plus, and the other one is what? CO32 minus, CO32 minus. Now in the reverse reaction, this H3O plus gives H plus to the carbonate ion. So it happens in the reverse direction. So this is the bronze chloric acid. This is the bronze chloric base. So now see this one. In the case of water, here the water acts as a proton. Here water acts as a proton accept. Here it accept proton. So it is what? This is a base. And water is what? H3O plus is what? It is the bronze chloric acid. So this is the donor of H plus. Since it is a donor of H plus, it is the acid. And that one's conjugate base is this one. So the conjugate base of that is CO3 2 minus. So that one, or B, is the answer for that. The answer for that is B. So the next one is, yeah. The next one is, we go to question number 22 now. We go to question number 22. In question number 22, pH of 1.5 moles per cubic decimeter. Solution of hydrochloric acid is. So that's quite easy question. Quite easy question. This is a Tute. That the easy question. pH of 1.5 moles per cubic decimeter solution of hydrochloric acid. So I have the solution of hydrochloric acid. So this is my HCl solution where the concentration is 1.5 moles per cubic decimeter, right? And then what the pH is, since that HCl is a stronger acid, it gives H plus ions and Cl minus ions. So HCl concentration is 1.5. So H plus concentration also 1.5. That is because it's a strong acid. Strong acids are fully ionized. So when I consider the pH is equal minus log H plus concentration.